Hey guys, so in the last unit we started to look at average rate of change. So we had things that weren't particularly linear and we just looked at specific sections or specific pieces of the graphs and looked for the average rate of change just in that section. So we're going to focus more on the truly linear aspect of it. And this goes right along with a lot of real world scenarios. So we're given a little short scenario. It says Kelly bags groceries at Publix. On average, she fills 21 bags for every 3 customers. So on average, why did that not switch? On average, she fills 21 bags for every 3 customers. So I circled average because, she's probably, everybody doesn't have the same number of grocery bags. Like, that's not going to happen. So on average, 21 bags for every 3 customers. So it wants us to graph Kelly's situation. Well, first we need to figure out who is the independent and who is the dependent variables. So does the number of bags depend on how many customers, or does the number of customers depend on how many bags? Well, we don't have any groceries to bag if we don't have customers. So definitely the number of bags depends on customers. So customers is going to be on my x-axis. And number of bags will go on my y. Okay, so it tells us we have on average 21 bags for every 3 customers. So 21 bags for every 3 customers. So I set this up like a ratio. Now this is a rate of change, okay? 21 bags for every 3 customers. If I want to find the average rate of change, I simply, simplify. So 21 is divisible by 3, so my average rate of change would be 7 bags per 1 customer. And I'm going to use this so that my numbers don't have to be quite as huge when I'm graphing. So 7 bags per 1 customer. Awesome. So I'm going to count by 7 with my number of bags, and customers, I'm just going to go by ones. So 2, 4, 6, 8, 10. I am counting by ones. I just only number every other because it gets too squished. So 7, 14, 21, 28, 30, 5, 1, 3, 4, 5, yep. 6 times 7, 49. I think that's probably enough. So I'm going to just go ahead and plot my points. So 7 bags for 1 customer. Average 7 bags, 2, 14, 1, 28, 35. You get the gist. Now, remember, don't just automatically connect your points. Ask yourself, am I allowed? Is this a discrete or a continuous function? Remember, continuous is not just that something goes on forever. It's, can I find the in-betweens? So can I serve 2.5 customers? No, not really. 2 1/4, yeah, that just doesn't make sense. So we are not going to connect these points. So this is discrete data. It is a discrete function. It is a function. It passes the vertical line test, but I am not going to connect these points. So let's go see what else. So graph Kelly's situation. Yep, we did. What does the average rate of change represent? Well, the average rate of change, so that's the key there. I'm going to highlight that. Average rate of change is how many bags per 1 customer. So that's our unit rate. Hopefully some of this is sounding familiar from old vocab. So it says, what is Kelly's average rate of change? So her average rate of change is that 7/1. That is her average rate of change. Awesome. So we're given another scenario about Nick and his friend Tommy. So Nick and his friend Tommy, they both mow lawns. Nick earns $375 a week mowing 15 lawns, while Tommy earns $500 a week mowing 25 lawns. Okay, so we got 2 different scenarios. It wants us to construct a graph that represents Nick's earnings per lawn mowed and Tommy's earnings per lawn mowed. Okay, so let's start with Nick. Okay, so I'll just stick with blue. So Nick's gonna be blue. So Nick earns $375 a week, mowing 15 lawns. Okay. So Nick earns $375 for 15 lawns. So I'm going to go ahead and see if that divide nicely and find my average rate of change. And it does divide nicely, so 25 over 1. So what does that mean? Well, this is money, so he gets $25 per one lawn that he's mowed. Okay, so let's look at Tommy. So Tommy earns $500 a week for 25 lawns. So $500 a week for 25 lawns, and that divides nicely. So $20 per lawn. Okay, so Tommy charges less, so he's got a smaller unit rate. However, he's got more accounts, so he's able to mow more lawns, hence he's able to make some more money. So that's where you got to figure out what's the best deal, charging more or charging less. So let's go ahead and construct a graph. So again, who depends on what? Well, the amount I make depends on how many lawns that are mowed. So our independent variable is the number of lawns and because the total cost, wait, is it cost? No, it's earned. Amount earned. Amount earned, money earned, however you want to do that. Amount earned depends on how many lawns are mowed. So number of lawns, 2, 4, 6, 8, 10. I'm just going to go ahead and number by ones. Okay, so amount earned. So I've got 20s and by 25s. I'm going to go ahead, because I know 25 will go into 100 evenly, so I'm going to go ahead and number by 20s. So 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. I know this is not showing all of our points. We're just looking to see the trends in the data. Okay, so Nick is blue. So 25, so one lawn is 25. So 2 lawns would be 50, so 20, 40, 50. 3 lawns, 75, so that would be 80, so come down a little, 75. 4 lawns, $100. 8 lawns, $200. I just took the easy one. So 5 lawns, $125. 6 lawns, $150. 75. Okay, and do I connect my points? Well, I'm thinking this is discrete data again, because nobody's going to pay me to mow part of their lawn. It's just not going to happen. Okay, so then we'll look at Tommy. So $20 a lawn. Okay, so I numbered by 20s. This will be nice and easy. 20, 40, 60, 80, 1. Okay, so we can see how Nick has a higher average rate of change. So we see his slope is a little bit higher. It's growing faster. Yeah, Tommy is making more, but that's just because he's having to mow more lawns. So what does the average rate of change for each graph represent? Well, their charge per lawn. So who has a greater average rate of change, and what does this mean in the context? So a greater rate of change is going to be Nick. And it just means that he charges more. So he's making more per lawn. Awesome. So average rate of change, we're really just going to focus and really dive deep into graphing things that are linear in this unit. So if you look at both of these scenarios, the one about Nick and Tommy, if we had 0 lawns, we're making $0. So they both have an initial of 0, 0. Same thing up here. If she has no customers, well, she can't bag any groceries. So we have no y-intercept so far. Well, we have a y-intercept. It's the origin. It's 0, 0. So we're going to get into where we have a different y-intercept, a different initial amount, and we'll kind of grow from there. Well, great job. Go ahead and try it out. See how you guys do.